All right. So again, we're looking at how to graph polynomial functions. There's two main ideas that we're going to do here with polynomials. We're going to graph them, and we're going to solve polynomial equations. All right, so you should get that in your mind right now. What our two goals basically for this chapter are graphing and solving polynomial equations. Okay. How are we going to solve polynomial equations? Well, we're going to use tools like factoring. We're going to use tools like the quadratic formula. We're going to use tools like, brace yourselves, here it is, polynomial division. Oh yeah. So to get us to polynomial division, though, we got to talk about polynomial addition and subtraction. That's section 5.3, and polynomial multiplication, which is also section 5.3. Okay, so those are the places we're going, but the end goal is to solve equations and to be able to graph. One of the key ideas of graphing polynomials is end behavior. Okay, so again, if we have an odd degree polynomial, okay, so if we're looking at the top part of this chart, if we have an odd degree polynomial, x to the 7th power, okay, and the leading coefficient of that is positive, then we expect to see a graph that looks something like this, where we get a tail out here and a tail here. We don't know what happens in the middle. You can't say what's going to happen there. The only way you know that is by using an XY table and then ultimately by confirming it with your graphing calculator. Okay. Likewise, if we have a even degree polynomial, x squared, x to the 4th, x to the 22nd, it doesn't matter. As long as the highest exponent is even, then we expect to see end behavior. Again, we're not talking about anything in the middle. We're just talking about end behavior where the tails go like this. And so an immediate application of this knowledge is a problem like this, which I should have already had the answer cleared off. I apologize about that. Maybe I circled the wrong one. Unlikely. But here we have a polynomial function, right? I just gave you a graph, and I give you 4 choices of what the equations could be. Okay? And so I know that an even degreed function like x to the 4th or x to the 4th, the tails should both be going the same direction, either both up or both down. Okay, so immediately I can rule these out. Those aren't right. Okay. And now I see that it either has to be x cubed with a positive leading coefficient or x cubed with a negative leading coefficient. And so I can return back to that chart if I wish or I forget, and I see that it kind of looks like this. Right? It kind of looks like this, where the tails are going out this way and out this way. So the leading coefficient must be negative. And so the circled answer here was A, is correct. Okay. And so that's an application of this idea. Taking it a little differently, if we want to graph, okay, so I'm asking you to graph here. At this point, I can use my knowledge of degree and end behavior to help me start graphing this. Okay. So the end behavior should look similar to the one we just looked at, where we kind of get a tail that goes like this and a tail that, maybe not quite like that, but goes like this. Now that's not very much of a graph, but it at least is a starting point. Okay. And so now how can I get the rest of the values? The answer is XY table. Okay, if I want to graph the rest of these values, I should have an XY table. Okay, and so let's pick an x value of 0. That's always an easy one to do. So if I take an x value of 0 and plug that in, I had to get out negative 1. So that means that must be a point in the graph. Okay. If I plug in an x value of 2, right, now I'm going to have to do a little bit more math here, but let's see what values we get out. Okay. So if I plug in a 2, 2 cubed is 8, but now it's a negative in front of it. So I get negative 8 here. And then 2 squared is 4 times 2 is 8, so this is negative 8, positive 8, that goes to 0. 2 times 2 is 4, minus 1 is 3. So the point should be 2, 3, 1, 2. It should be up there. Okay. Let's see what happens when I plug in negative 1. Okay. And again, we're just going to pick several points. Probably to do this well, you should pick 1, 2, 3, 4, 5, maybe 6 points to really have a good sense of what's happening and the inside there. Now, I have some experience graphing polynomials. I know you might believe that. But I would also, after we probably get 3 points here, tell you to rely on the graphing calculator to kind of fill in some of the missing spots. Okay. So let's try -1. Let's see what information this gives us. So -1. So -1 cubed is -1, but then this turns into a +1. So this is +1. This is -1 squared, which is 1 times 2, which is 2. So this is 1 plus 2 is 3. -2, which is 1. -1 is 0. So if I did my math right, it looks like for the point -1, we get something like this. And this is probably enough for us to get a pretty good idea of what the graph looks like. Okay. So I'm going to do this in orange now and see what we can pick up. So maybe something of that nature. Okay. So again, my approach for you, how I want you to solve these problems, is I want you to first start with end behavior. Okay, start with where the tails are supposed to go. Secondly, make an XY table. Give me a couple values. Put a couple dots here to give me some idea of what should happen. And then lastly, we can use a graphing calculator to get the rest of the details. Okay. All right, let's take a look at another one. And this time, I'll have you guys working on it a little bit by yourselves. If you're watching the video, please pause it in just a moment. So the first thing I see is that this is -x to the 4th power. -x to the 4th power. So that means that I expect to see some tails that are going like this and like this. Now, I have no idea what's going to happen up in here. Up in here. So to answer that question, we'll make an XY table. We'll make an XY table. And so we want to pick some values like -2, which they actually ask us to pick. So they ask us to plug in -2, so you should do that. I'll tell you the easiest value always to plug in is 0. 0 is a nice one, right? So if I plug in 0, I get out -1. So that's got to be the point there. And then you should probably plug in maybe another 1 or 2 values like 1 and 2 to really get a sense of what's going on here. And the bigger degree function, the more values you should pick, right? Because the higher this degree, the more intricate things that can be happening inside the center. All right. So at this point, I want you to pause the video, work on filling out the rest of the XY table. Again, remember, you get to pick the X values. I chose a couple here that make sense, but you pick the ones that you want to do and try to complete what this graph should look like. Okay. All right. So after going through and doing a little bit of the arithmetic, we have 4 values. Of course, -229 is off of the graph. So now we have to somehow piece this together. Now, for most of you, these 3 points is probably not sufficient for you to see what's going on here. That's why you need to either get more XY values or just rely on the graphing calculator from here. But with some experience, I think you'll see that the graph looks something like that. Okay, and if you look at the graphing calculator now and try to validate and verify that, I think you'll see that you're going to see a graph that resembles something of this nature. Okay. And so this is the idea of graphing polynomials. Obviously, we're not going to get too complex. Big idea is seeing end behavior. Next idea is XY table to fill in the gaps. That's graphing. Why do we use the graphs? The graphs will help us to see where the zeros are. Right, this is one way to solve equations, where if I asked you what is this equation when it's set equal to 0, you can see there are 4 solutions. Here, this x value, this x value, this x value, and this x value. Okay, and that idea we will see in later sections. Okay, so this concludes section 5.2. Let me make sure that's true. Yeah, this concludes section 5.2. And so thanks for your attention. We'll see you next time.